The next thing we're going to do is we're going to find extrema of functions. Okay? When you see the word extrema, it's kind of the plural form of extreme values. And really all you need to remember that word means is maximums and minimums. Okay? So when you see the word extrema, I'm really just asking you to find maximums and minimum values on particular graphs. Okay? And you're going to get to use Desmos. This is pretty simple here. Okay? We could use calculus to help us, but we're not there yet. So, okay? So we're just using technology. So anyway, the word extrema just means maximums and minimums. I'll either give you an equation that you'll have to type into Desmos, or I'll give you a picture, and you just pull everything off of that picture. Okay? It's really pretty simple. There are 4 things you will find as far as extrema. You'll find absolute maximums, absolute minimums, local maximums, local minimums. Absolute max means the highest point ever on that function. Okay? So the highest point ever on a function will be your absolute maximum. The lowest point ever on a function will be your absolute minimum, or your lowest value. A graph does not have to have absolutes. So sometimes your answer is none. Okay? Local maxes and local mins, those are just like tops of hills and bottoms of valleys. Okay? They don't have to be the absolute highest value, but they're kind of the highest value if you look right around it. Okay? So if you look at this graph right here, you want to take a guess what this coordinate 4, 6 is?
Local maximum.
It is a local maximum. It's definitely not the absolute maximum because it's not the highest point on this graph, but locally, if you look to either side of it just a little ways, you'll notice it's bigger than the other values around it. So 4, 6 would be the coordinate that represents a local maximum. Okay? See local minimums?
-3, -1.
-3, -1. There's a local minimum. Let's talk absolute. Do you see an absolute minimum?
-8, 10.
I said absolute minimum.
Oh.
Negative.
Okay. If there's not a finite value, if it's not a specific number, then there isn't one. This would be none. The graph goes down forever, doesn't it?
Mm-hmm.
So is there ever a lowest value? Nope. Because whatever number you say, I guarantee you can go a lower one. And then I guarantee you can go a lower one. So this would be none. How about an absolute maximum? -8, 10. Highest point, nothing ever gets any higher than that, so there's -8, 10. Okay? Some coordinates can be absolute and locals. Okay? Let's say I had a graph that looked like this, right here. This coordinate right down here is both an absolute minimum and a local minimum. This coordinate is just a local minimum. This is a
Local max.
local max. Does this graph have an absolute max?
No.
No. So pretty basic on that?
Yeah.
Everybody alright with that? Okay. The other thing you'll do with these is you will write the intervals where the graph is increasing and where the graph is decreasing. So what you kind of think is, okay, I'm going to start at the very left-hand side of the graph, and I'm going to trace the graph. What am I doing right now? Increasing or decreasing?
Decreasing.
I'm decreasing. So in other words, I was decreasing from here to here. Then once I get past this coordinate, now I'm increasing, and then now I'm decreasing. So when I go to write my intervals of increasing and decreasing, though, I use my x values. I kind of do it like I do domain. Remember how we talked about domain? All x values from -infinity to -2 and so on. Okay, we'll do it the same way. So in other words, this graph is decreasing from where to where?
-8 to -3.
-8 to -3. And then from -3 to 4, it's increasing.
And from 4 to 7, it's decreasing.
And then from 4 to, does it stop? Doesn't it keep, as I keep moving along this way, doesn't it continue to decrease?
Yeah.
So from 4 to infinity. Not negative infinity, we're not talking y values, we're talking x values here. Okay? So this graph is decreasing from -8 to -3, and then it's decreasing again from 4 to infinity. Where everybody makes mistakes is they start thinking they gotta list y values here, and that's not the case at all. Okay? You're listing the x values where the graph is increasing or decreasing. Questions? On Desmos, I'll give you an equation. You'll type that equation into Desmos, and you'll be able to identify where these tops and bottoms are, and you should be able to identify absolute maximums, absolute minimums, locals, and everything else pretty easily. Any questions on that? Do you want to see one on Desmos? Feel like you can do it? Okay. All right. So, last chance here, vocabulary questions. Extrema just means what?
Min max.
Mins and maxes. Feel like you know how to find your mins and maxes?
Yeah.
Do you understand the increasing and decreasing interval part?
Yeah.
Okay, remember, just left to right. Everything's left to right. Okay? You should hit every number that's on the graph. So we hit every number from -8 to -3, and then we covered -3 to 4, and then we covered 4 to positive infinity. So we hit every x value that's possible. This one didn't have an arrow, so the very leftmost point of this graph was -8. All right.